You've been there before. You type something into an AI tool. The result is, okay. So you try again, rephrase it a little. Still not quite right. You try a third time. A fourth. A sixth. And somewhere around attempt number 7, you stop and wonder, is this thing actually useful, or am I just getting lucky? Here's the thing. The problem is almost never the AI. It's the approach. And today, we're going to change that approach completely. What we're covering in this video is called deep prompt engineering. And before you tune out thinking this is just about writing fancier questions, it's not. Not even close. Deep prompt engineering is closer to system design than it is to creative writing. It's the discipline of structuring how you communicate with language models so that your outputs aren't just occasionally impressive, they're consistent, reliable, and scalable across thousands of uses. This matters whether you're a developer building automated pipelines, a content team trying to produce at scale, a researcher who needs factual grounding, or a business professional who's tired of getting different answers every time you ask the same question. By the end of this video, you'll understand why most AI prompts fail, what separates a one-time lucky prompt from a system that works, the exact frameworks practitioners use to engineer reliable outputs, and the mistakes that quietly undermine everything, even in well-built workflows. Let's get into it. Most people treat AI like a conversation. You ask something. It responds. Sounds simple enough. But here's where that mental model breaks down. Real AI communication, the kind that produces consistent, useful outputs, actually involves 4 distinct elements. You have the instruction, what you're asking for. You have the context, what the model needs to know in order to do it well. You have the format, how you want the output structured. And you have the constraints, what you explicitly don't want. Miss any one of those 4, and the model doesn't crash. It doesn't throw an error. It just fills in the gap on its own. And that gap filling is exactly where inconsistency lives. This is what makes AI failures so tricky. Unlike a piece of code that breaks loudly, a language model that misunderstood your prompt still produces output. It just produces the wrong output, often one that looks completely reasonable at first glance. In a high-volume workflow, those quiet errors stack up fast. Now here's where things get interesting. The people who figured this out first, developers, researchers, practitioners who were using these tools before they were mainstream, they went through a very specific evolution. Phase 1, they discovered that phrasing mattered. Ask something one way, get a shallow answer. Rephrase it, and the model suddenly performs like an expert. That felt like finding a cheat code. People started collecting good prompts, the way they saved useful bookmarks, a little treasure trove of phrases that seemed to work. Phase 2, they started asking a different question. Not, what words work, but, why do certain structures work, and how do I make that repeatable? That shift, from magic phrase to repeatable structure, is where prompt engineering was born. And from there, it evolved into something even broader, what practitioners now call context engineering. Designing not just a single prompt, but the entire information environment the model operates within. Think of it this way. A surgeon doesn't just show up and start cutting. The operating room is prepared. The instruments are arranged. The team knows their roles. Every variable that can be controlled, is controlled. Deep prompt engineering applies that same preparation logic to AI communication. So what are the actual principles behind this? Let's go through the most important ones. Principle 1, precision over length. When AI outputs feel off, the instinct is to add more. More instructions, more context, more explanation. And sometimes that helps. But more often, it creates a new problem, a long, bloated prompt where the model loses track of what actually matters. Precision is about reducing ambiguity without increasing noise. Every sentence in a prompt should do real work. If a line can be removed without changing the model's behavior, it should be removed. Here's a simple test. Read your prompt and ask yourself, what could someone reasonably misinterpret here? Everywhere the answer is, quite a bit, that's not a place to add words. That's a place to rewrite. Principle 2, context design and information hierarchy. Not all context is equally important. And here's something that surprises most people. Models are actually sensitive to where in a prompt information appears. Instructions near the beginning or end of a prompt tend to carry more weight than those buried in the middle. So structure matters. Your most important constraints go first or last. Supporting information fills the middle. And optional context either gets labeled clearly or removed entirely. Principle 3, constraint-based prompting. Most people write prompts that describe what they want. Fewer people think carefully about what they don't want. Constraints, output length limits, formatting requirements, scope boundaries, behavioral rules. These narrow the space of possible outputs the model can produce. And a smaller, better defined output space almost always means more consistent results. Here's the key distinction: keep it concise is not a constraint. Respond in no more than 3 sentences, that's a constraint. Specific, testable, enforceable. Principle 4, role framing. Telling the model to take on a specific role, say, you are a senior technical editor reviewing a first draft, can meaningfully improve performance on tasks that benefit from a defined professional perspective. It shifts the model's tone, depth, and vocabulary. It activates different patterns from its training. But, and this is important, role framing is not a magic fix. Overly elaborate personas can actually get in the way of clear task instructions. Use it strategically, when a specific viewpoint genuinely improves the output. Don't use it as decoration. Now let's talk architecture. Because the best prompts, the ones that power reliable workflows, share a consistent internal logic. Think of it as 4 layers. Layer 1, input. What is the raw material you're working with? A document, a topic, a dataset, a user question? Define it explicitly. The vaguer your input, the vaguer the output. Layer 2, context. What does the model need to know to handle that input well? Background information, audience specifics, domain constraints, prior decisions. Keep this focused. You're filling knowledge gaps, not narrating your entire thought process. Layer 3, process. What should the model actually do? This is where most prompt writers spend the most effort, and they should. Specify the reasoning approach, the steps if there are multiple, any checks you want the model to perform along the way. Layer 4, output. How should the final response look? Length, format, structure, tone, what to include, what to leave out. If you want a table, say so. If you want 3 bullet points, say so. If you want flowing prose, specify the depth. Now here's the diagnostic value of this framework. When a prompt starts producing inconsistent results, you can run through each layer and ask, which one is underspecified? 9 times out of 10, that's where the problem is. Here's where things get even more powerful. Once you have a prompt that works, you turn it into a template. You replace the variable content, the specific document, the specific topic, the product name, with clear placeholders. The structure, instructions, and constraints stay constant. What changes is only the input. A prompt used once is a tool. A prompt used 1,000 times, consistently producing quality output, that's infrastructure. And good infrastructure gets versioned. If you improve your template in week 3, you want to know exactly which version produced which results. That matters for quality tracking. It matters even more when something starts going wrong and you need to find out why. But some tasks are genuinely too complex for even a well-designed single prompt. That's where prompt chains come in. The idea is straightforward. Break a complex task into sequential steps. The output of step 1 becomes the input of step 2. Each link in the chain handles one well-defined task. The model gives each step its full attention, rather than trying to juggle everything simultaneously. You can even add validation checkpoints between steps, a simple check prompt that confirms the previous output meets basic requirements before it moves forward. That small addition makes the whole system significantly more resilient. Let's talk about the techniques that actually move the needle on reliability. Because this is where theory becomes practice. Instruction layering. Complex tasks have requirements that don't all carry equal weight. Layering means organizing those requirements by priority. Primary objectives the model must meet, secondary preferences it should aim for, and edge cases it should handle gracefully. Why does this matter? Because when instructions conflict, even subtly, the model has to make a judgment call. Instruction layering tells the model how to make that call. If your primary goal is factual accuracy and your secondary goal is a conversational tone, you want the model to know. When those two things pull in different directions, accuracy wins. Output standardization. If you are running AI at any meaningful scale, standardizing your output format may be the single highest leverage thing you can do. When outputs follow a consistent structure, defined headers, numbered sections, clear fields, they become dramatically easier to review, easier to integrate into downstream systems, and easier to audit. You eliminate a whole class of formatting decisions the model would otherwise make on its own. Testing. Real testing. A prompt that has been tested once is not a validated prompt. It is a promising candidate. Real validation means running the same prompt against varied inputs, including edge cases. Short inputs, strangely formatted inputs, inputs that seem almost designed to confuse the instructions. It means running the same prompt and input multiple times, not just once. Here's why that last part matters. If outputs vary significantly between identical inputs, your prompt is leaving too much to the model's discretion. High variance is almost always a sign that something is underspecified. Error reduction at the source. Most prompt errors are preventable, and most of them come from the same 4 places. Ambiguous instructions. Missing context. Inconsistent input formats. Conflicting requirements that the model has to silently resolve on its own. Address these before deployment. Reviewing prompts for ambiguity, normalizing inputs, and explicitly resolving conflicts in the instructions themselves. This is far more efficient than debugging errors after you're already in production. Everything we've covered so far applies to a single practitioner. But most people eventually need to operate at a larger scale, across a team, across an organization. And that's where governance becomes the differentiator. When a team relies on AI for any significant volume of work, the prompts powering that work become organizational assets. They should be documented, versioned, owned, and maintained, just like any other critical piece of infrastructure. A prompt library is a centralized collection of validated templates with clear documentation: what each prompt does, what inputs it takes, what outputs it produces, known limitations, version history. That's not bureaucracy. That's how you prevent the same problem from being solved 5 different ways by 5 different people, and how you make improvements visible and reusable across the whole team. Now, automating AI workflows doesn't mean removing human judgment. It means placing human judgment at the right points in the process. Most production workflows benefit from a layered review structure. Generation is handled automatically. Basic format and length checks run in the background. Human reviewers sample outputs at a frequency proportional to the stakes involved. High-risk, low-volume tasks get closer attention than low-stakes, high-volume ones. And if you skip the feedback loop entirely, quality drifts. It degrades slowly, invisibly, until the problem is large enough to be undeniable. Checkpoints aren't overhead, they're what keeps a system honest. Underscore 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 underscore. Section 6. Advanced Techniques. 2100 hours to 25:30. Music. Focused. Intellectual energy. For those who want to push further, here are the advanced patterns that practitioners use when standard approaches aren't enough. Few-shot prompting. Instead of describing what you want, you show it. You provide the model with 2 or 3 examples of the task, demonstrating the tone, the format, the reasoning style, before asking it to perform the task itself. This is especially powerful when the desired output has qualities that are hard to specify in instructions but easy to illustrate. A particular editorial voice, a specific analytical approach, an unusual structural format. Show, don't tell. It's not just good writing advice. It's good prompt design. Structured output prompting. Rather than asking the model to format its response however it sees fit, you give it a template to populate. The model fills in your structure rather than inventing its own. Formatting ambiguity essentially disappears. Post-processing becomes dramatically simpler. Integration with other systems becomes reliable. Self-evaluation. Here's a simple but surprisingly effective technique. Ask the model to review its own output before delivering it. You can add a single instruction at the end of a prompt. Review your response for completeness and accuracy before finalizing. It doesn't give the model new knowledge, but it does catch surface-level issues, missing sections, logical gaps, instructions that were half-followed, that might otherwise slip through. For high-stakes outputs, running a dedicated verification pass as a separate prompt is even more reliable. Retrieval-augmented strategies. When tasks require factual grounding, current information, proprietary data, domain-specific knowledge, the most robust approach is to bring that information directly into the prompt context rather than relying on what the model already knows. This grounds the model's output in a specific, reviewable source. Combined with explicit instructions to work from the provided material, it significantly reduces the model's tendency to produce confident, plausible-sounding claims that aren't actually accurate. Before we get to real-world applications, let's talk about what not to do. Because even experienced practitioners make these mistakes. Overloading a single prompt. It feels simpler to put everything in one place. In practice, prompts that try to do too many things at once tend to do all of them worse. If a task has clearly distinct phases, a chain of focused prompts will almost always outperform one monolithic instruction block, assuming the model understands implied intent. This is the one that catches even careful practitioners off guard. Models respond to what is written, not what is meant. Instructions that seem perfectly obvious to you carry none of the accumulated context a human colleague would bring. When your intent matters, write it out explicitly, even if it feels redundant. Skipping evaluation. A prompt that works today may underperform 2 months from now as your inputs evolve, your use cases expand, or the underlying model gets updated. Prompt engineering is an iterative discipline. Regular evaluation, not just initial testing, keeps systems calibrated and catches regression early. Chasing trends instead of building durability. There is always a new, breakthrough, prompt technique circulating. Some of them are genuinely valuable. Many are context-specific and won't generalize to your situation. Building around durable principles, clarity, precision, testability, structured output, will consistently outperform building around whatever worked in someone else's demo last week. So where does this all land in the real world? In content and publishing, prompt engineering enables editorial teams to scale volume without sacrificing consistency. First draft generation, structural outlining, style conformance. Well-engineered prompt systems handle all of it. The human editor's role shifts toward refinement and judgment rather than generation from scratch. In software development, structured prompts power documentation generation, code explanation, automated review checklists, test case drafting. The reliability requirements in this domain are high. Inconsistent documentation and missed edge cases have real downstream costs. In education and research, AI workflows support literature synthesis, study material generation, and knowledge organization. Factual reliability is the central challenge here, which puts retrieval-augmented approaches and explicit sourcing requirements at the center of the design. And in business operations, the often overlooked category, the volume of routine text generation tasks inside most organizations is enormous. Drafting communications, summarizing meetings, maintaining consistent support responses. Even modest consistency improvements at that scale add up to significant operational gains. Here's where the field is heading. As context windows expand, from thousands of tokens to hundreds of thousands, the design space for AI communication changes fundamentally. You can now bring entire document sets, extended histories, and complex instruction hierarchies into a single context. But bigger context windows don't solve the underlying challenge. A model with access to 100 pages of material still needs guidance about what to prioritize, what to treat as authoritative, and how to navigate conflicts within that material. Information hierarchy and context design become more important, not less. On the governance side, as AI-generated outputs become woven into organizational workflows, the question of how to maintain quality, audit decisions, and handle failures is moving from best practice to operational requirement. Prompt documentation, version control, and structured review processes are becoming the foundation of responsible AI deployment. And what about human expertise? Better models don't make human judgment obsolete. They change what that judgment focuses on. Decisions about purpose, audience, ethical boundaries, and strategic direction remain fundamentally human responsibilities. Prompt engineering, at its best, is the discipline that lets human expertise operate efficiently at scale, not the discipline that replaces it. Let's bring this together. The shift that actually matters isn't technical. It's conceptual. Moving from, how do I write a better prompt, to, how do I design a system that reliably produces good outputs? That question changes what you pay attention to, and what you build. Reliability doesn't come from finding the perfect phrase. It comes from structure, precision, and testing. Scalability doesn't come from using AI more aggressively. It comes from templates, governance, and feedback loops. And the human expertise that makes any of this valuable doesn't diminish as the technology improves. It refocuses on judgment, on oversight, on the decisions that genuinely require it. Build systems, not just prompts. Test them, not just use them. And treat every output as feedback on the quality of your input design, because that's exactly what it is. If this video gave you a new way of thinking about AI communication, drop a comment below. I want to know, what's the biggest prompt challenge you're dealing with right now? Let's actually talk about it. If you found this useful, hit the like button. It genuinely helps other people find this content. And if you want to go deeper on AI systems, workflow design, and the practical side of working with language models, subscribe. We go into this level of detail regularly, and there's a lot more coming. Up next, how to build a reusable prompt library for content, research, and automation workflows. It's the practical companion to everything we covered today. See you there.
Yeah, came through flexing cause they know I got the sauce. Got the presence on me, I can't ever take it off.